Hello friends, welcome back. Hope you are enjoying this training. So now we have come to the most interesting layer of the OSI model, which is the heart of the OSI model, and we are going to talk about the transport layer. So this slide is packed with a lot of animations that will help you understand how the data is transferred at this particular layer, and we are going to see all those aspects of TCP, UDP, sequencing and reassembling and much more that goes here at this particular layer. So thank you so much for tuning in till this time. So journey here onwards is going to be simpler, easy, and I hope I'm able to give you all those insights on how the data is actually being transferred when it comes to network connectivity. Friends, like this, there are many more beginner courses that I have created. Those courses will lay your foundation and act as a launch pad for getting into the domains like desktop engineering, system engineering, or it could be cyber security. So it's my personal experience, and if your concepts are strong, you need not to depend on anybody or research around when there is an actual need to investigate some issue. So friends, with this, let's move on to our next layer, which is the transport layer. Hello friends, so let's start with the transport layer. So we have discussed about the application presentation session layer. So talking about the transport layer, so transport layer is responsible for end-to-end connectivity. It is also known as the heart of the OSI model, and the tasks performed at this particular layer are identification of service, then multiplexing and demultiplexing, then we'll be talking about segmentation, then the sequencing and reassembling, and the error correction, how it happens with the help of the remote data link layer, and finally the flow control. So friends, there are two types of services which are primarily used. Number one is TCP and other one is the UDP. So when it comes to TCP, this is known as transmission control protocol. UDP is known as user datagram protocol. So TCP is connection oriented, whereas UDP is connection less. So when we talk about TCP, when you send a packet, you get a response for that, and that's what makes it connection oriented. So when we talk about UDP, it is one-way communication, either the packets are sent or received. So as there is no acknowledgement from the recipient whether that packet is received, that is the reason we call it as a connectionless. So here in the TCP service you get the acknowledgements, but in the UDP we do not get any kind of acknowledgements. Now, as there is an acknowledgement, this is pronounced to be a reliable protocol, whereas UDP is said to be unreliable. But even if this is unreliable, it helps in quickly sending or receiving something. There could be some loss, right? But end of the day, not all services need kind of reliable acknowledgements, right? So it could be a service where it's just that you need to send your voice, send an image, right? Share your screen. Not necessary that every time you should receive the acknowledgements, right? So in such situations, UDP comes handy. So that's where this is known to be faster as compared to TCP. So TCP is slower as compared to UDP. Now coming to the port, so while we do the analysis, the packet analysis in the Wireshark, we'll see the port numbers. TCP uses port number 6, whereas the UDP uses port number 17. Now talking about the examples, so HTTP, FTP and SMTP are some of the examples of TCP. What that means is these protocols, the HTTP protocol makes use of TCP, FTP makes use of TCP, and an email service SMTP also makes use of SMTP. Whereas DNS is a DNS resolution protocol. Host on the network sends a request to resolve that DNS name. So name to IP resolution has to be done by the DNS server, but it's not necessary whether the host is able to or the client is able to reach to that particular destination by the DNS server. So friends, that's where it is using UDP. So same goes here. If a client requests for an IP address to a DHCP server, it doesn't need an acknowledgement. So once the request is received, the DHCP server responds back to that request regardless of whether the client has received the IP or not. So the same thing goes with TFTP, and these are the basic differences when it comes to service identification, which is TCP and UDP. So I hope you have got clarity on these two services. Now coming to the activities done at the transport layer. So this layer ensures end-to-end delivery. It means if there is a problem with the communication, this layer helps correct those problems. Then so TCP and UDP protocols again work at this particular layer. So error correction is done by the transport layer. It plays a crucial role if some packet is lost during the communication. This layer helps send that particular lost packet to the destination. Then moving to the attack vectors here, man in the middle attack is one of the well-known attacks that goes here. So this is one of the our most sought after attacks in cybersecurity. So in my cybersecurity training, I have covered how this happens, and I will get more insights there once you complete the beginner courses. Now, the SYN and ACK flooding. So we have discussed in the previous sessions that TCP uses SYN, SYNAC, and ACK. So these are the communications. It's a three-way handshake, and that happens when data is transferred using TCP service. So in this case, SYN and ACK, these packets can be flooded by an attacker uh, to uh, to impact the functionality of the remote server. So if a flood of traffic is sent, the server becomes busy, and that's where you can plant another attack. Now moving next is the TCP/IP vulnerabilities. So there are port level vulnerabilities. Then there are many other vulnerabilities associated with this particular layer. Then the main function that we are going to discuss here is the different activities which are performed at this particular layer. So session layer, you understood that session ID is attached to the communication or the packet. Now moving to transport layer, first thing you need to know is identification of service. So if you see port number 6 is being used during the communication, then it means it is a TCP packet. And if you see UDP, then the port number is going to be 17. So this is the primary thing that goes here. Now consider I have two hosts. So we come to the critical part of the uh, transport layer, and I have created a beautiful animation that will help you understand how the segmentation happens at this particular layer. So segmentation. So here consider you send a message, hello, how are you? And now this is the message that you are going to send. So what happens at transport layer is that this message is divided into small segments, and these segments are sent to the destination. So could be you are transferring a file in GB, right? It's a gigabyte file, it's a big file. You cannot transfer that 1 GB data in one go, right? So you need to segment that into small segments and send them one by one. And then subsequently, once all those segments are received at the destination, then it will recompile those segments to extract the data that you actually transferred. So we have seen that the hello, how are you, this is created, and now the segments are being sent. Now on the computer B, the segments are received. Not necessary that all the segments should be received in sequence. So it could be like you, hello, how, question mark, and you, right? So now the message looks like this, and this is not something that we are expecting. If you look at the way it is displayed here, so if you look at the data, this is where reassembling or sequencing comes into picture. So consider now this is the data that is received, right? So this is not something that we want. So what happens here is when you send a message, it is first turned into small segments, and these segments are now sequenced, right? So if I go back here, you can see 1 of 5, 2 of 5, 3 of 5, like this. Some sequence number is attached to each segment. It's not in this format. I have just tried creating a slide which would help you understand, right? And we are going to see that in the Wireshark. So now the destination receives them and processes them. Now, friends, it's not necessary that these segments should be received in sequence. So, consider this is the message. You have segmented that message and it is sent. But it may happen that the data is received in this fashion. So, are we expecting this kind of data transfer? No. So, in order to overcome this problem, sequencing and reassembling was introduced. So, what happens here is the computer sending the message will first segment the data, and after this is segmented, it will be sequenced in this fashion. Now that the data is now segmented, it is being sent. Now you have the data received by the computer B. It will first receive all those segments and then it will reassemble them in proper sequence. Now the data is being sequenced and it will be displayed in the correct fashion. Now moving to error correction. So error correction is the function of transport layer. So here, suppose you are sending the data. So sequencing has been done, segmentation has been done, packets are being sent. Now the destination has received some of the segments, but one segment went missing. So after reassembling, the destination computer finds that there is a packet that is missing. And this error detection, I'm not talking about error correction. Error correction is the functionality of the source transport layer. So it is the functionality of transport layer on this computer, the sender. But detection of the error is done by the destination data link layer. And if the destination data link layer sees some error, it will report back to the source transport layer. And then, so this is where you can see it is reporting back to the source, segment is missing, and now transport layer of the source computer will only send that missing packet, I mean the missing segment, to the destination, and that will be received and reassembled, and finally the message will be displayed. So this is how the error correction is done by the transport layer in the OSI model. So now flow control. Most of the times you might have come across situations. Suppose you are downloading some movie from internet. Sometimes it shows 5 minutes left to download. Sometimes it shows 7 minutes left. Sometimes it may show 4 minutes left. So there is a continuous fluctuation in the time period that you see remaining to download a particular file or movie from the internet. And why that happens is because the network bandwidth is continuously fluctuating. Sometimes you'll be able to download more data, but if there is a congestion on the internet, it may hamper the speed with which you are downloading the data from the internet. So that's where flow control comes into picture. So windowing is one of the functions. So here what happens, suppose the client a computer A sends 3 window. Now the client has received all those 3 windows. Now it will revert back that I have received those 3 windows. So it means the computer A can understand that sending 3 windows is going smoothly. Now it will try to send some additional window. Now here this time it sends 5 window. Now the client has received 4. It means that now, so acknowledgement for only 4 window has been received. Now here you can understand that computer A can send only 4 segments, right? Nothing but the windowing function that goes here to the computer B at a time. So that's where the flow control is also controlled using transport layer. So transport layer, so at application layers, port numbers, HTTP, HTTPS, all that is applied. Then the data is converted into presentable format, that the format that can be used on the network. Example, EBCDIC, ASCII, lot many things we have already discussed. Then session layer, session is established, session is maintained, and session is terminated, right? And finally at the transport layer, the layer attaches the transport header, and data at transport layer is in the form of segment. So this is the very important thing that you need to understand.